Hi friends, welcome back to our channel Physics Tutorial. This is the part 9 video of electric charges and fields. So today we are going to discuss continuous distribution of charges. Can we move to the video? The topic continuous distribution of charges is actually needed for our next topic, that is for Gauss's theorem. Okay, so here we have to understand that what is continuous distribution and what are the different types of distribution of charges. Okay, so for applying we have to know the equation also. Only that much is enough. So what is continuous distribution of charges? What is the meaning? Yes, is it mean that it combines to form a single charge? No, it is not like that. It means that the charges will be very close to each other. All the charges will be placed very close to each other, and it will not be a single charge. Okay, so in such a case we have to consider different types of distributions. That is, linear distribution is there, surface charge distribution, and volume charge distributions. Now we can just go through linear charge density, surface charge density, and volume charge density. The first case is linear charge density. It is represented as lambda. Okay, so charge per unit length is called linear charge density. So linear charge density means charge per unit length. In this case we are considering the charge as a line distribution. Okay, so here we can consider a very small length delta L, right, and the charge will be the small amount of charge present over this length delta L. Now how we can write linear charge density? That is lambda is equal to delta Q by delta L. Only this equation you have to remember. Lambda is equal to delta Q by delta L is the linear charge density. Okay. The next topic is surface charge density, that is represented as sigma. Okay, so in the case of surface charge density we have to consider the continuous surface charge distribution. That means the charge will be distributed over a surface. So in such a case, suppose delta S is the small elemental area and delta Q is the charge contained in that area element. Okay, then how we can write the surface charge density? Surface charge density is charge per unit area. Okay, so how we can write? Sigma is equal to delta Q by delta S, that is the charge per unit area. It is called surface charge density. The next point is volume charge density. Okay, it is represented as rho. And in the case of volume charge density, we have to consider the charge as a continuous volume distribution of charges. Okay, so in this case, here delta Q is the charge contained in a volume delta V. Okay, then we can write the volume charge density rho, that is equal to delta Q by delta V, that is charge per unit volume. It is called volume charge density. So these three equations we have to remember. Only 3 points we have discussed now, right? What were the points? Linear charge density lambda, that is equal to charge per unit length, that is lambda is equal to delta Q by delta L. Then surface charge density, that is charge per unit area, that is sigma is equal to delta Q by delta S, and volume charge density, that is charge per unit volume, so delta Q by delta V. So just understand the three equations. Hope it is clear to you. If you like my video, please like, share and subscribe. Thanks for watching.